Some of you might remember this from last year. Those who were there with me last year, we did start this. But anyways, it'll be a good revision. All right. So the first thing you need to learn is that logs are very close to indices. All right, and the reason why that happens is because logs and exponentials are opposites of each other. And an exponential, if you remember this from your functions you were doing before, are 2 to the x. So x is on the top. Those were called exponentials, right? Then that base can be any number. So you can like have 3 to the x. That's still an exponential. And then the opposite of an exponential, just like the opposite of addition, let's say, the opposite of an exponential is logs. So the opposite of exponentials are logarithms or logs. The opposite of addition is subtraction. Opposite of sine is inverse sine. It's important that you know opposites. So to get rid of a square root, what was the opposite of a square root? You would have squared it. So to get rid of exponentials, we're going to do the opposite, which is logging. So we're going to need that logic. Don't worry, we'll be working a fair bit of this obviously today. But to start, you need to relearn your index laws or review your index laws, which comes from exponentials. So beginning should be easy. We remember 2 bases when multiplied. What do we do to the indices? Add them. When we divide bases, what do we do to the indices? Subtract. A power to a power, you multiply, and vice versa. A lot of students are very aware of this version to this version, and they keep forgetting these versions, the right-hand side to the left-hand side. Be flexible with your math, and the reason why I say that, that's really important. I mean, if I wrote this one, let's just say 4 to the x, right? A lot of students can't see 4 to the x is actually 2 squared, let's say, to the x. Isn't that the same? Because that's technically 4, and then 2 squared is also 4. So I could write 4 to the x as 2 squared to the x. And then I could write this again as 2 times x, 2x. Or I could even rearrange these two and write this as 2 to the x, all squared. All right, see how they're all literally the same thing. So you've got to learn to be able to go from the right-hand side also to the left-hand side. It's an important skill. Please, as always, just stop me if I'm going too fast or if I'm saying something that you don't understand. Power of 0, anything to the power of 0 is 1. Negative indices are fractions in the denominator. So if it's a negative index in the numerator, then it's a positive index in the denominator, and other way around. If I've got a negative index in the denominator, it's a positive index in the numerator. And then if it's a fractional index, then that becomes the xth root of a to the 1. So the denominator goes in the square root, or in the root, in the surd, and then your power of 1 in the numerator goes as a power. Or in a different way, if you want to write this, p on q becomes qth root of a to the p. Now I guess most students I've seen memorize this have just said, maybe it goes in a clockwise motion. Some have said this, p is on the top, p is going to be on the top, and then q, and then q. So it goes like a clock, and that can work really well. The way I personally think about it is p is on the top, so p is going to be on the top as a power. Q is on the bottom, of course, then that's just going to be on the bottom, somewhere down here. And that's my logic, but whatever works for you, this should have already been memorized. A slightly more neglected rule, I believe this should be part of your laws that should be taught, but unfortunately it's not. So we do make it a law for us, and we just say it's a more neglected rule. It says that if I've got 2 terms that are multiplied and it's all to the x, then that's the same as me writing, of course, each one to the x. Now, most of us are pretty comfortable with doing that. If I gave you a question, so if I gave you, I don't know, 2x to the power of 2, I think most of us would have done 2 squared x squared, so it's 4x squared. The problem is it's not these ones that are that applies really well to this particular question. It's these cases, 6 to the x. So 6 to the x was two numbers that multiplied to get you x. You're actually allowed to break up 6 to the x as two different bases, as long as the powers are the same. So the idea is if you actually want to multiply bases that are different, you're allowed to, as long as the powers are the same. And that's obviously this rule, just showing you in a different light. Okay, I'll pause there. Any questions? No? Everyone's happy with everything so far? All right, brilliant. Let's move forward. These are, I guess, just revision of index laws. I think for now we can skip, well, we'll skip that one. I feel like you guys can do that. I'll just jump and try this one, and then I'll leave the rest for you to do for homework, and I'll send you the solutions to them. So there shouldn't be a big problem, but I'll just show you the ones I'm really interested in, which is these type of questions. Now this doesn't really come up in your exponentials and logs. Obviously this is more of a revision of term 1. 2 to the n plus 1. Can anyone tell me how to break up 2 to the n plus 1?
2n plus 2n1 or
2n plus 2n1. Yeah, you were close. 2n times 2 to the 1.
Yeah, I meant times, sorry.
Yeah, because when you multiply your bases, what do you do to your indices? You obviously add them. So that would be absolutely correct. And then minus 2 to the n over. Same thing with this. You're just going to write 2 to the 2n dot 2 minus 2 to the 2n. Okay, any questions from anyone? Anyone not sure how we got these powers out?
Could you explain it again?
Right.
Sorry.
Yeah. Yeah. So if I gave you this, if I gave you x to the 5, give me two numbers that can add up to get you 5. Go. X to the power of what?
4 and 1.
All right. And what else?
3 and 2.
Okay, cool. So pretty much you can add up 4 and 1 to get you 5. And you can add up 3 and 2 to get you 5. And why are you adding in the first place? Because you're multiplying your bases. So when you multiply, you add. Now, that's an easy case that you understand. But the idea is if I've also got x to the, I don't know, let's say 3n times x to the power of 4n. Okay, what would that become? X to the power of what? Well, 3n plus 4n. Isn't that what you would just do? Which would give you 7n.
Yeah.
And vice versa. Can't I break up 7n as 3n and 4n? Or even 2n and 5n, and I can just be here all day. The other one is n plus 1. Well, you know you can't add unlike terms. See, these were like terms, 3n and 4n, so they add to give you 7n. If they're unlike terms, well, that's just going to be x to the n times x to the 1. What are you going to add this? What's going to happen when you multiply your bases? N plus 1. What about that one? What's the answer for that? X to the what?
X to the 3n, and then it's going to be times x to the 3.
Yeah, and that makes sense. Again, look at it. Your bases are multiplying, so that's fine. Then what do you do to your indices? You add them. What's 3n plus 3? Well, it's still 3n plus 3. You can't add these. They're two unlike terms. Perfect. Anybody else? Or is that cleared up now? Brilliant. Okay, and then I've got this, and I mean I've got the top and I've got the bottom now, and I'm looking at it and I'm like, well, there's a common 2 to the n, so I'm going to factorize that out, and then you're left with 2 minus 1. 2 minus 1. Again, think of the expansion of this. It'll give you 2 minus, and then there's nothing there, so you got to write 1 over. Factorize 2 to the 2n from here. again, what are you left with? 2 minus, well, there's nothing else, so 1. 2 minus 1, 2 minus 1 is just 1, but they can just cancel out anyways. All right, now what do? Bases are the same. What do we do to the indices if you're dividing?
Subtract.
Subtract. So n minus 2n is obviously negative n. And you're done. All right. Any questions? Like I said, that's not part of logs, part of indices. Maybe if we've got a bit of time into the lesson, we'll come back and review these. But I don't really want to look at them any more than we need to for now. All right, logs. Now, the way you would have been taught in year 10 when you did do logs, just at school 5.3 stage, your schools probably should have taught you logs. You would have learned a definition, and the idea of the definition is if I've got an exponential, I can actually convert this exponential to a log using this particular formula. Now, you will not see me using a formula. We're going to actually understand how to move from here to here so that we can apply it every single question, regardless of the difficulty. This only works really well if you've got a question that says 2 to the x equals, let's say, 7, and then the formula says you can write it as x equals log y, which is 7, and a little sub-base of this number here, which is 2. Well, that's great, but it only works if it's specifically like this, which obviously you're not going to get questions like this by the time you come into year 12 especially. So we're going to, my way, we're not going to learn this formula at all. Right, what we're going to do is actually prove it every time. So a little bit more annoying at first, but it actually will pay off in the long term. I can promise that. So if you learn this, just remember, I never taught it to you, so you don't need to worry about it. It's not an issue for you. Okay, just like index laws, we've also got log laws. They sound pretty similar. So you got to get this wrapped around your head. So let's have a look. When you add two logs, so log x plus log y, when you add two logs, it's the same as logging just these two multiplied. So the log of two terms multiplied is the same as adding your two logs. So log x plus log y. Sounds familiar, right? Comes from your index laws. If they're multiplied, you add the indices. Well, that's the idea. If these two terms are multiplied, you add your logs. Of course, if they're subtracted, what do you think? Divide, right? Log x minus log y is the same as log x on y. You divide, subtract logs. Okay, probably the second most important one. The most important one is going to come up. The second most important one would be this power one. If you've got a power, you're allowed to bring your powers down. That is very, very helpful, because powers are usually pretty complicated to deal with, but think about it. I mean, again, think about this power. If I had a log in front of this, I could just bring this power down. Wow, that's amazing. Like it was so difficult, but by the time I bring it down, it just makes it a lot easier. So if you've got a power, your powers can just come straight down. Okay, we're going to prove this one as well once we learn the most important rule. But log of a with a little sub base of a, that's not a to the power of a. Right? Powers are like that. So that would be a power. This is log a and then sub base. Sub base. That's what I call it. Your teachers might call it something else. But if they're the same number or the same letter, it's always 1. And if you're logging 1, it's always 0. And just since we're here, we're going to do graphs probably next lesson. Graphs won't be this lesson, but log graphs look like this. And if you can see something, you can't log 0 and you can't log negatives. So log has to be greater than 0. You can only log numbers that are greater than 0. You can't log 0 and under. So your domain, if you want to talk about domain and be fancy, x must be greater than 0. Your range, everything works, all real y's. There's no problems with that. But your domain, x must be greater than 0. If you want to try it in your calculator, log is on top of cos, or ln is on top of tan. Just press log of 0 or negative numbers and you'll realize they won't work. It'll give you math error. Okay, let's have a look at some of these questions now. Well, let's first see if we know how to apply this. So if I gave you log of 2x, what is that equal to? Well, I know they're multiplied, so I could also write it as log of 2 plus log of x. That's the first index law. If I've got log of x cubed, how can I write that? Well, again, I can just bring the 3 down. Because I know powers, I can just bring them down. What's another one? What if I had log of x cubed on 2? What would be my first step for this one?
You minus?
You have to minus first. Why didn't you bring the 3 down first?
Oh, because it's a fraction.
No, because the 3 is not attached to the 2 as well.
Okay.
So if it was all cubed like this, you could have just brought the 3 down and then subtracted. But because it's not attached to the 2 as well, you have to do log x cubed minus log 2. And then again, what do you do with the power of 3? Bring the power down. All right, let's see this applied. So, given log 2 equals m and log 3 equals n, write the following in terms of m and n. Now, you can probably see there's little a's there. But because they're all a's, they're all the same sub-bases, I can tell you for now, you can ignore them. All right? They're not going to be an issue to you. And it's probably just going to be a bit easier for your first lesson to start off without having all your little a's everywhere. So you can just assume I told you log 2 is m and log 3 is n. You don't need to say log 2 subbase a is equal to m. You're going to confuse yourself. You're going to confuse your brain. You don't need it. Just say log 2 is m, log 3 is n. Write the following in terms of m and n. We want to find log 4. So the idea is all of these numbers are these two numbers just hidden. And we've got to find that out. And that's the way you're going to pretty much start off with your basic logs. So log 4. Anyone tell me what I can change 4 into?
2 squared.
2 squared. And then what are you going to do next?
Bring the 2 in front.
Bring 2 in front. And then you've got 2 times log 2. But what does log 2 equal to?
N.
M. So that becomes 2m. Good job, Anouk. B. Who wants to try this one? Log 27.
3 cubed.
Equals log 3 cubed. Again, what do we do now?
Bring the 3 down.
Log 3. What does log 3 equal to?
N.
And then the answer is
3n.
Easy. C. Before you guys continue, has anyone actually done logs this year yet? Yeah, I didn't think so. You will learn logs I think from what I see with schools, it looks like it will be next term, or maybe end of this term. So the schools are really behind. But anyways, so you guys are killing it. If you can master this and master calculus, hey, you guys are super doing well. All right, log 1.5. Log 1.5. Who wants to try that one? 1.5. Special number.
Log 3 on 2.
Log 3 on 2, absolutely, which equals?
Log 3 minus log 2, which is
And
m minus n.
And
n minus n.
yeah, that's easy. Done. It's not hard. Obviously, you need to be really pro with your log laws, which aren't too difficult, right? Don't make them more difficult than I've just made them. So that's it. That's all you need to know. Log 12. Who wants to try that one now? Log 12. Novak?
Log 2 squared
Oh, yeah. Log 2 squared times?
times 3.
Yeah, exactly. So log 12 is 4 times 3. 4 is 2 squared times 3. What do you do when they're multiplied? Add. And then bring the 2. Well, we already know the answer to log 2 squared. You bring the 2 down, and then it becomes 2m. So that's 2m plus log 3 is n. E log 18. Well, kind of the same logic, isn't it? 18 log 9 times 2. 9 is 3 squared times 2. So you're realizing like these numbers are pretty much, all of these numbers are these two numbers just hidden. And that's the way you have to actually attempt these. Some are going to be a little bit harder to see than others, but the logic's always the same. Log 3 squared is 2 times log 3, so 2 times n plus m, and then log 13.5. 13.5 is 27 over 2. Again, we already know what log 27 is. We've worked it out somewhere here. There it is, 3n minus m. Anybody have any questions for me? No? All right. Let's move on to a HSE question. 2-unit HSE question 7. So log B subbase A is 2.75. Log C, A is 0.25. Find the value of log B on C. What do we do? Log B minus log C. I might write the little a's now so you guys can see how they work. Well, there it is. Log B is just 2.75. Log C is 0.25. How easy was that for a HSE question? 1995. What do you do with the power of 2? It's attached to the whole thing. So you first bring the power down. And then log BC becomes log B plus log C. You know, these little a's if you want to write them. Log B is 2.75. Log C is 0.25. All right. I'll pause there. Again. Copy that down. Any questions? Or is it all just making sense now? No questions. Let's try a few different. Let's try from this booklet as well. It says log B is 3.14. Log C is 2.45. Find log B on C. What would you do for log B on C? Subtract. Log B minus log C. Log B is 3.14 minus 2.45. Plug that into your calculator. 3.14 minus 0.69. Ooh, that changes it up a bit. Log of square root of BC. Anyone have any ideas?
Would you put it to the power of 1/2?
You must. Exactly like calculus. You can't have it there. Power of half, and then what would you do, Nova?
Bring it down.
Bring it
1/2.
down. You got half, and then you're left with half of log BC. But you know these are multiplied, so you might as well just save a line and go log B
Plus log C.
plus log C. Log B 3.14 plus 3.14 plus 2.45 times by 0.5 is 2.795. And last one, triple I, log B cubed on C squared. Well, I think we get it. I would first subtract their different powers. So I'll first subtract, then bring the powers down. And you're done, right? 3 times log B, 3 times 3.14 minus 2 times 2.45. No dramas. Okay. Anyone still copying from that or writing anything down?
Yeah, I'm still copying.
All right, I'll wait for you.
Yeah, I'm good, Sam.
Okay. Very good, very good. Write each of the following. Yeah, I think again, a little bit of homework or a little bit of your own work, but look, log 3, 81. 81 is 3 to the power, I'll do the first one so you understand. 81 is log 3 to the power 4. Bring the 4 down. There it is. Write each of the following as log 3s, 4 log 3s. So log 81 is 4 times log 3s. And then you're just going to do that for each case. Yeah, we can read. Yep, we don't need that. Don't need that one. All right. So this is probably the most important one. Change of base. That should be part of your laws as well. What it is we've obviously seen questions now that have said like log 3, same line, and then this is a little number at the bottom, so log 3 sub base 2. Now we would like to work out what this is on our calculator. If you go ahead and actually try to use your log on your calculator, which is on top of your cos, you'll realize all you can put in is just log 3. You can't actually put that number at the bottom. So there's got to be a way to actually put this into our calculator. And that way is this particular formula. To change your bases for your logs, it is just a fraction of log of the top over log of the bottom. Oh, that's so easy, right? So now you can actually plug that into your calculator and go ahead and try that. So press your fraction button and then log 3, close your bracket, over log 2, close your bracket. You should get 1.584 blah 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 blah. All right, everyone's done that? Any questions about that? No one, anyone not able to identify where log is? Okay, now look at the one right next to log. What does that say? It says, some see it as in, it's ln, so ln. Now you would probably see me use ln way more than log. So every time I say log, I actually mean this log, not this log. Now that's just confusing, but you will get the idea of it. The difference between the two is just in regards to their bases. Now logs have a base 10. And what that means is every time we're counting, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we start again. 11, 12, 13, 14, 15, all up to 20, then you start again. 21, 22, 23, 24, 25, 26. If you get to 30, you start again. So they go up into increments of tens, right? That's how we count. That's the way we've learned numbers pretty much from primary school up to today. So that's what logs does, log. ln, however, has a base e. Has your log with a base e. Now, e is a number. If you want to know what e is as a number, it's just like pi. So e is, I think, 2.71. You can just press shift. Whoops. What are we doing? You can just press shift ln, and then your calculator will see an e and a little, a power. Just put 1. So if you press shift ln, you press 1 in there, you show, 2.718, right, blah, blah, blah. It's irrational. It's just like pi, but e is a number. Now, what log does is it repeats it every e. So it repeats it every 2.718, blah, 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 every single time. Now, the reason why these are good is because this whole topic is called what? Logs and exponentials. And I did say at the beginning that these two are opposites of each other. So what we want is a form or a log that would work well with its opposite value. So ln is going to be probably the one that you will see me use a lot more than log. I don't think I've ever used log except if the question specifically only said just to go and do log 3, just log 3, which you'll never get in an exam or any question except probably question 1 in your textbook. But everything else, when you're going to solve and everything, we'll need ln's. Now, you can, when you're writing it, it's okay to interchange, but especially for it being your first lesson. But eventually you want to move your logs to ln's. So every time I say log, it's this log. I might write this log, but I still mean this log. Okay. Hopefully that hasn't confused everybody. But ln and logs are the same logs, it's just different bases. So they're both logs. Okay. And what is a log? I'm sure someone's going to ask that question or someone's thinking about it. Log is just like, it's just another function, right? So to understand it really well, you probably have to get into more university style of work, but it's just another function for you at the moment. Just like sine is a function, cos is a function, square rooting is a function, squaring something is a function, adding is a function, subtraction is a function. Logging something is just another style of a function. It's just doing stuff to something. So that's all I can say for you at the moment. But yeah, logs. Okay, equations involving indices and logs. So change of base. If I've got something like this, now we know we can write this as ln x on ln a, log x on log a. Sounds good? Log x on log a. So examples, let's say log, plug that into your calculator, log 5 on log 3. ln 5 on ln 3. 1.46. 49, blah, blah, blah. Okay. Any questions? We're good. Really important tool to know how to do a change of base. And the reason being because we're going to eventually solve logs. And if you don't know how to convert from this into a fraction, so you can actually do equations work, you're going to get stuck. So probably the most important, second most important was the power one. So let's say we've got a question like this and it says solve. Up to today, you might have not known how to solve if it was a number or a base here that wasn't from a base of this. So the ones you've learned have been like this. I don't know, 3 to the x is 9. You got taught that 9 is, and therefore x equals 2. What if it wasn't a base of this? So like 7. 7 is not a base of 2. Well, then you're stuck, and that's where this guy comes in. All right, so let's do this. This is 2 to the x, which is an exponential. What's the opposite of an exponential?
Logging.
So you're going to log both sides, right? Just like you would have said, I don't know, let's say this number. I don't know, let's just say if it was that. It's weird. How do I get rid of the square root? You square both sides. Correct? That's how we've been doing them, right? All right, so like this one here, same thing. How do I get rid of the, oh, well, I mean, it's an exponential. You'll get used to that, I can promise you. You log both sides. So pretty much you've got this right now. Now, I really hate the x being up there because, you know, we're used to solving for things that are in what, like, you know, a line at the bottom, x is on one side, and that's it. So this is really annoying. What can I do with the x?
Can you bring it down?
You bring it down, right? That's the whole point of what we're trying to learn here. So you're going to bring the x down. X log 2 equals log 7. And then what would you do, Chan, to get rid of log 2? Careful.
Would you bring it to the? Would you divide it by?
Yeah, just divide. Good man. The reason why I said, and that's it. Plug that into your calculator. You should get 2.807. The reason why I said just be careful with this point. Let me just make a different point to you guys. Look, this one here for trig. How do I get rid of sine? Just sine. You would say inverse it, right? Or shift it, or whatever you guys are getting comfortable with saying. There. That's how you get rid of sine. So therefore you're left with theta. But that's different to if I said this. How do I get rid of sine 40? You won't say, oh yeah, shift it or inverse. You're trying to get rid of a whole number here. Sine 40 is just a number. To do that, you've got to think of the times. So the opposite of timesing is dividing. And that is that question. So be careful, there's a difference. How do I get rid of sine? How do I get rid of sine 40? If you want the sine 40, you're just going to divide it, add it, subtract it. If you just want to get rid of sine, you want to keep theta, then you've got to think of how do I get rid of just sin, just the sine bit. And that would be inversing. And that's the same thing here. How do I get rid of just log, oh, so how do I get rid of all of log 2? He said divide it. But if I ask you, how do I get rid of just the log? You're going to say exponential. All right, for now, we're doing well. So let's start from the top again. 2 to the x is 7. We decided to log both sides, and obviously we understand why we log both sides, because I can bring this power down. And then, of course, you just divide. So 99.99% of students, I can tell you, around the state, just memorize. If you've ever got a question like this, it's just log of the right-hand side over log of the base of the left-hand side. But I mean, it's good to know where it's coming from. And that was the proof that I was saying. Your teachers could just do this in one line. They would probably be writing, you know, log 7, 2. You got to memorize that. We're proving it so we understand what's happening every time. And the reason why we prove it is because it's pretty much you're going to get these questions in exams. There it is, Extension 1, North Sydney Boys, Extension 1 Prelim Yearly, 2010. And again, you guys can see how we structure these booklets. We structure these booklets like one theory question, or two maybe theory questions, and then pretty much exams, right? It's not like your textbooks where you keep going through like 1,000 of these and getting really comfortable with them. It's great, but you're never going to see these in your exams. You're going to see more, you know, exam style questions. So same thing with you guys. You've got to jump straight to exam questions once you're comfortable. You've got to start learning to move away from your textbook questions. You can't repeat what you pretty much did in term 1. It's not going to pay off long term. Rewrite 2 to the x equals 5 to the y with x on y as a subject by taking logs to a suitable base. All right, who wants to try this one?
Yeah, I'll do it.
Go ahead. What would you do?
So you'd ln both sides, right?
Log both sides. Yep, beautiful.
And then you'd bring the x and the y down.
X log 2 equals y log 5.
Yeah. And then you'd get x over y equals ln 5 over ln 2.
Oh, too good. Anyone confused about that step? That's a really important step. Anyone not sure what he's just done? Brought the y over, he divided the y. Because you don't want the log 2 here either, you're going to divide that over to the right hand side. And you pretty much get the result they want. X on y as a subject. There it is. Any questions? No. All right. Hence or otherwise, well, you got yourself 1 mark, enough, well done. Hence or otherwise, find the exact value of 8 to the x on y if 2x equals 5 to the y. What would you do now, Enoch? 8 to the x on y equals 8.
It's a square root, right?
Oh, no, you don't need to even worry about it like that. You're way too hard. Forget that.
Okay.
What's x on y equal to?
Oh, yeah, ln 5 over ln
Yeah,
2.
that's all. You just did the hard work. And then now plug that into your calculator.
Okay.
I don't even know why this was worth 2 marks. Maybe the first one should have been 2 marks. And the
It's
second one.
125.
Yeah. It's weird. Anyways. Anybody have any questions for us? Okay, cool. Oh, not yet. All right. Not yet. So let's not do exponentials just yet. Yep, let's do logs. I think we're doing well with logs. Okay. Let's learn some log equations. So we're going to solve using log equations. Chan, let's start with you. 2 log x sub base 3 equals log 6 take away x sub base 3. Now, eventually we've got to get rid of the logs. Obviously, we don't like the 3's there, and I don't like the 2 there. There's a lot of things I don't like that we've got to, fix up first. So the first bit is going to be this 2. What are you going to do with the 2?
Would you bring it on top of the x?
Correct. So you are going to actually do that, and I'll explain that in a second, but that's good. So bring the 2 up as a power. Now, what do you know? How do you know to write these sub-bases? See these 3's? They're both 3. I don't like them there, because I can't really do much with them being there.
Bring them forward?
No. So that was their change of base. So that's going to be log of x squared on log of 3, which equals to log of on log of. Does that make sense?
Yeah, alright.
Now, what you can learn, and obviously what extension students should just know, is if you've got same sub bases here and here, you know this is going to happen every time, right? It's going to be all over log 3, all over log 3. Well, you can just get rid of it, can't you? Because what are you going to do now when this is all over log 3 and all over log 3? You're just going to cancel it out, right, Chan?
Yeah.
So if they are all the same sub bases, brilliant. You're very happy with that. You can just cross them out from the beginning, and you could have just written, log x squared equals log 6 take away x as your first line. But obviously, as you get stronger and stronger with it. But just so you guys know, if you've got the same sub bases, you can pretty much get rid of it. Okay. Now, the reason why you have to move this 2 over is because you can see now I've got 2 logs. I need to get rid of logs, and you can only get rid of logs if they are both monic. So if one's monic and the other one's not monic, like this 2, you actually can't exponential it. All right. So Chan, you're at this stage. You're very close. How do I get rid of my logs?
Uh,
What's the opposite of log?
exponentials.
So you're going to exponential. Now, again, it's a very fancy way of saying it, but pretty much this guy and this guy will always just cancel out, right? Because it just like you having this. So what's the opposite of square root? Cancel. Exponential, you're crossing it out. Now, some students eventually get to this stage. That's not a problem as well. It's good to know why you're actually doing that. So they just go, oh yeah, cancel log and log, because they're both on the same side. Oh, yeah, that's fine. That's not an issue, but it's good to know you're actually exponentially it, and that's why it cancels out, not just because it just cancels out. All right, Chan, what are you left with?
X. So would you bring one side over?
Yeah, you would, but just do it slower. So x squared equals 6 take away x, and then bring it over. And that looks pretty familiar, right?
Yeah.
And then, do you know what the factors are?
X plus 3 and x minus 2.
Therefore, x equals.
Minus 3x.
And obviously, you guys maybe remember from me, I just said before, log cannot be a negative. You can't log a negative 3. Try it out if you want. Try logging negative 3. It won't work. So that's no solution there. Therefore, the only solution is x equals 2. We're going to do a lot of log equations, so don't worry. That's your first one. This will be in your exam, and it will be worth, in your HSC, probably 2 marks. Yep, it won't be 3 mark. Good 2 marker. All right. Any questions? Any lines anyone's confused about? We did extra lines that we don't really need to, just because the beginning. I thought we'll do a few extra lines. But there's no questions. Let's try this one. Again, who wants to try this? Maybe one of the girls. Log 16 take away log x equals log 8 take away x. I'll walk you through it. Just come on. All right. Shania, let's do this one together. Log 16 take away log x equals log 8 take away x. Like I said, to get rid of your logs, it has to be log on one side and then equal to log on the other side only. So I can't have 2 logs that are subtracted like this and go, oh yeah, let's just exponential it. The reason why you can't do that is it's the same reason as why you couldn't do it when it was like this. Root x plus root y equals 5, let's say. You can't go, oh yeah, square individual terms. You never did that. If you wanted to square something, it was squaring the whole side. So, same logic. You can't do anything with it until they're put together. So what are you going to do with log 16? Take away log x.
Can I break down 16? I'm not sure what I'm supposed to do.
You don't need to. No, you don't need to. So you don't like the subtraction sign there. Think of your log walls.
Divide?
Yes, 16 on x. Look what you've just done. You've got log now and a log here. How good's that? Because what can you do with the 2 logs?
You can exponential it.
Yeah, and pretty much they'll just disappear. So you're left with 16 on x equals 8 take away x. What you just said with your powers, like 16 is 2 to the power 4, you only do that for the other styles of questions where it says, I don't know, log 2 is equal to like a and log 3 is equal to b, and then try to work out what log 16 is.
Okay.
So that's not really solving, that's more
breaking it down, I guess.
Yeah, breaking it down. I think they use the word evaluate for those ones. Whereas solving, you're actually trying to find x. Okay, we're here, 16 on x. What would you do at this stage? I don't think you like the x here.
Oh,
Oh,
so you times x. Sorry.
Yeah, that's fine. That's fine. And then bring everything to one side. So you got x squared minus 8x plus 16 equals 0. And then can you see your factors for that one? I think they're the same, actually.
Yep.
X, take away
4.
4, and next take away 4 again. So therefore your only answer is? Now
X
be
equals
careful.
4.
Perfect. Now be careful though. Sometimes with logs, even if you've got an answer, once you sub it in, if it gives you negative anywhere and it doesn't work, you can actually write no solution. So just because it works mathematically, it doesn't mean it actually works for the beginning. So just be careful with that. Let's sub in 4. Well, log 4 is not a problem. 8 take away 4, it becomes 4. That won't be a problem either. So in this case, that's perfect. You're done.
Okay.
So again, recap what you did. I said you can't have 2 logs on the one side. It has to be only 1 log before you can exponential. So we have to somehow combine this into 1 log using our log laws. And then
Get rid of the logs.
pretty much you get rid of the logs and just do it, right?
Yep.
Yeah, cool. Anybody else have any questions for us? Anyone confused? No. Okay. Let's look at this one. This is what last year's from Normanhurst Boys High School. Extension 1, task 2. Find the value of x if log 2 subbase a plus 2 log x subbase a minus log 6 subbase a equals log 3 subbase a. What can we do with all these subbase a's?
They can all go, right?
Why?
Because you divided by ln a.
Yeah, so technically they're all going to have log a, log a, log a, but if they're all on the same side, you might as well just cross them out.
Yeah.
Yes, good job. So you're left with log 2 plus 2 log x. See how I keep interchanging? I'm doing that on purpose, but it's just so that you guys get more comfortable with writing ln instead of log. And if you do write log, it doesn't really matter as long as you, in your calculator, you try to learn to use ln. All right, anyways, we're here. The right-hand side, I guess I'm pretty happy with. It's just got 1 log. The left-hand side, I really hate. I don't know what is happening here. So something's got to happen. Who wants to try it? Again, I prefer one of the girls. Emily, let's try this one together. So we're going to use our log laws for this. Let's do this. Let's do the first 2 together first. Can I add these straight away? I can't because of that 2.
So do you make it an exponential thing? So it's ln 2 plus ln x squared.
Yep. Bring it up, and then minus still ln x, ln 6, sorry, equals to log 3. Now they're added, so what can I do when I add 2 logs?
It's the product law, so it's
Product law, beautiful. And then, I mean, if you want to do it in 1 line, what do you do when you subtract?
it's divide, isn't it?
So do you want me to write it like that? Does that all make sense? To be able to do that in 1 line?
Yeah, kind of.
Yeah, so you added here, so therefore you multiplied those 2. This one's a subtract sign. You're going to divide that one. How do I get rid of the logs?
You put the e so it can get crossed out.
Yep. Exponential, pretty much gone. Eventually, as you guys get stronger and stronger, I think you will avoid the e. You'll just go, oh yeah, log's gone. Once you only have a log on one side and a log on the other side, it can't be any number in front of it. Okay, so you're left with what? 216 is the third. All right, there.
Then don't you times the 3 over, so it comes x squared equals to 9, and then doesn't it equal 3?
Careful.
Oh wait, minus the 9 over.
Oh, no, you were right.
Oh,
What's the opposite of squaring?
oh, a square root.
And then
So
what do you put right at the front?
plus minus.
Yeah, good job. Plus minus 3. Then we pause for a second. We just check. So if I sub in negative 3 into here, log of negative 3, we know won't work. Won't work. So therefore, the only answer
It's
is
a
what you said.
positive.
Yeah.
Yeah.
But if you don't actually show the plus minus 3, we can't give you full marks. So just be careful with that. All right, that was great. Well done. I know it's first day, so don't worry, you guys are doing really well. You're just getting everything where you're up to right now. You're killing it. Let's do some more. Let's go maybe to, yeah, we'll go to this one first. What I'll rather do is, okay. 2 log x equals log 4x plus 5. 2 log x equals log 4x plus 5. Queenie, what would you do first?
Bring the 2 up.
So it'll be log x squared equals log 4x plus 5. And then pretty much you're exponentialing, or you're just getting rid of your logs. Yes,
Bring
and
it
then
all to one side. X squared minus 4x plus minus 5 equals 0. X minus 5, x plus 1. X equals 5, negative 1.
and then
You check.
yeah, you should check. Because look, don't just think because it's a negative that it's wrong. It's only when you sub it in. So if this wasn't just x, if this was actually, what's one I can give you? If this was 3 take away x, when you sub in negative 1, 3 take away negative 1 actually gives you a positive number. So negative 1's not a problem. 5 is a problem because 3 take away 5 is negative 2. So this one would be wrong. So don't just, get used to crossing out all the negatives. It doesn't work like that. You got to check. So you sub it back to the top. Because you're logging a negative 1, the x equals negative 1 won't work. So therefore your only answer is going to be x equals 5 in this case. If you sub in log 5 and then 4 times 5 is 20, 25, it works out. All right. Let's try double I. Actually, I might get you guys just to try it yourselves before I say anything. I'll give you about a minute, just maybe write it down, play around with it. Okay, double I, log x plus 3 minus log x minus 1. Again, it's subtracted, so I would write log x plus 3 on x minus 1 equals to log 3. How do I get rid of the logs? Again, you can exponential it, or you can just get rid of it. And then You're left with x plus 3 on x minus 1 equals 3. Bring it to one side. It's easy after that. What's this? 2x. 3 plus 3 is 6, so x equals 3. Sub it back in. 3 plus 3 is 6. 3 take away 1 is 2. You can log positive numbers. The only answer is x equals 3. Any questions about that? Do the same thing.
It's supposed
Yeah.
to be a -3. Shouldn't it be -6?
Minus 3, but then when I bring it to this side, 3 plus
Oh, yeah.
3,
Okay.
6. And then what I did is I brought 3x and I subtracted the x.
Yeah. Thank you.
Good. Triple I. Try it, but I'll give you a clue before you get it wrong. This has a 3. This has a 3. This, there is no log subbase 3. So you can't cancel it out. You have to write it over log 3 still. But look at IV, 7, 7, 7. Yep, you can just get rid of it. Doesn't bother you. This one, log E. Well, log E is specifically ln. So, but you can just get rid of it. E gone, gone. This one you can't. So you're meant to still have a common denominator of log 3, and then I'll give you guys, yeah, just a minute or two to have a think about it. Maybe just play around with it. And again, we'll go together. Okay, so log x plus 1 subbase 3. So that becomes ln x plus 1 on ln 3 minus log x minus 1 on ln 3, which equals to 2. Now, that's obviously a common denominator of log 3. You don't want any fractions when you're solving, so you're going to multiply it over, and you would be left with this. Right? You would have multiplied your log 3 over, and you're left with that. That looks pretty close to what we would like it to be, right? This now, we know it's subtracted, so I'm going to divide that. And then I know I can't have this 2 here because I can't actually cross out my logs unless it's log equals a log. Then I bring the 2 up, and then now I cross it out. And I'm sure we should be able to continue from here. And then someone just gave me the answer. And let me know if you've got any questions about what we just did as well.
It should equal 5 over 4.
5 over 4. All right. Anyone disagree or not sure how you got that?
How'd you do that?
You would have multiplied by x minus 1. So let's have a look. Maybe I'll just write this bit out. Multiplied by x minus 1, so x plus 1 equals 9x, take away 9. Brought the 9 over to this side, which is 10. Brought the x over to this side, which is 8x, divided by 8. that becomes 5 over 4. 10 over 8, 5 over 4. Once you plug it into your calculator. Make sense?
Yeah.
All right, let's go another next one. IV. The good news with IV is that it's all 7, so you can pretty much write it the way I'm writing it for you now. There. So 2 log 4 equals half log x plus log 2. Try it again. I'll give you a few minutes to work on that. You don't like the numbers in front, and you don't like the plus. All right, this 2 becomes 4 squared. Half becomes log x to the half, and then plus log 2. When I'm plussing, this is going to become log of 2x to the power of a half. You multiply. And then what do you do with your logs? Again, gone. You've got 16 equals 2x to the power of a half. And then the first thing to do is to get rid of the 2, so you divide it. And then how do I get rid of a square root? Power of 2, right? A lot of students are not sure of that because they're like, half, I've only seen the square roots. But don't forget, half is a square root. So you just get power of 2. And that's it. Check it. 64. Yep, works. No problems. Any questions? Anyone getting to this step by themselves? Getting stuck somewhere? Alright, let's do a few more. We'll say 2 log x plus 2. Log 2x plus 1 plus log 8 take by x. Bring the 2 up, add, you're going to multiply these two things. Okay. Who wants to try to do this with me?
Yeah, I'll go.
Go ahead.
So you'd square the x plus 2, and then you'd go ln bracket 2x plus 1 times 8 minus x. Then your ln's cancel out, and then you expand and simplify, and you should get a quadratic.
Are you up to that stage already?
Yeah, I'm just solving the quadratic right now.
Okay. Maybe I'll stop there and let others ask me any questions as well. Maybe they can give a chance to solve the quadratic here as well. Anyone confused about what we've done? Anyone have any questions? Anoop, tell me.
Oh yeah, I got x equals 4 as the solution, because the other one was minus 1/3.
Minus 1/3. Wait, what did I say? Did you check it? Did you sub it in? Or
I
did you
thought
just go, oh, yeah.
negatives, yeah, would
Nah,
work.
wrong. Negative 1/3. What's negative 1/3 plus 2?
Oh yeah, okay.
Works. What's 2 times negative 1/3? Negative 2/3 plus 1 is 1/3. Works. 8 take away negative 1/3. Works. So
Yeah.
your assumption was wrong. Don't do that.
Okay.
I said it just up here. So don't just go cross out negatives. Actually sub them in.
Okay.
Be careful. All right. Okay. If we don't have any questions, that's pretty much log equations done. Right? Yeah. I'll get it to graphs. So that's log equations done. Let's do exponential equations. It's probably easier to start with this. Okay, exponential equations now. So obviously a bit different to log equations because you can see they're exponentials. There is a trick for these, and the trick is they're actually just hidden quadratics. So once you understand that they're hidden quadratics, you know they've got to be in this form. You know, ax squared plus bx plus c equals 0. Some of us might be able to even see it straight away. Hidden quadratic. So therefore, what? Once you know it's a hidden quadratic, the next trick to this is you always let your substitution be the middle expression. So e of x. So you let m equal to e of x, and then of course, what are you left with for I? Well, you'll be left with m squared because e of x is m. So e of x becomes m squared minus 4m plus 3 equals 0. Factorize. You can see how important term 1 was, which is why I emphasized really strong algebra. You've got m equals to 3 and m equals to 1. You weren't solving for m, you were trying to solve for x. So obviously you're going to substitute e of x back in. So instead of m equals 3, you write e of x equals 3. And this looks pretty familiar, doesn't it? What do we do to solve for x? How do we get rid of exponentials? Log both sides. So then the x comes down. I'm sure we know what log e is, right? They cancel out, it just becomes 1. But if you want to keep that in your calculator, you can. I'll just show you what you would write. If it was not e, you would put in over log e, just like we did before. But otherwise, log e is just 1, like I said. So you can just put, the answer is log 3. Same thing, log both sides. This becomes x, log e cancels out, log 1. Log 1, if you plug into your calculator, it's 0. So your answers are 0 and log 3. Okay. Any questions about that? Exponential equations? Okay, double I. Let's try it again. What would m equal to in this case? Still the middle term, right? E of x. But what's this? E2x. That looks really weird. Can anyone tell me a different way of writing this so we can just see what this is?
E2 times EX? I don't know.
E2 times EX. Oh, let's talk about what you just said, because it's important that you learn the difference between that one. E2 times EX. What do we do when the bases are the same? We add the indices, right? So
Yeah,
what you
sorry.
just, it's okay, it's good. What you've said is this one here, E2 plus X. So be careful. What I think you were trying to say is this one, E2 to the X.
Yep.
And
Okay.
yeah, because they're multiplied or product to product. And then, I mean, another way to write that, because we don't really want the X on the outside, is EX all squared. So really, this guy is just the exponential squared, which means it will just be m squared minus 5m minus 6. Does that make sense? And then minus 6 plus 1. M equals 6, m equals negative 1. You weren't solving for m, you were solving for x, so sub it back in. Log both sides, but you already know if I log the right hand side here, you can't log the negative, so there's no solution for that one. This one, when you log both sides, x comes down, log e will cancel out. Your answer pretty much just becomes log 6. All right. Any questions? Now we should know how to solve for logs and for exponentials. All right, let's see. What does, so it's 3 to the 2x minus 12 times 3 to the x plus 27. Instead of choosing e is just a number, remember that. It's not a letter, so it's a number. Just like pi is a number. Instead of being e, it just says 3. So what does m equal to in this case?
X
Did you say just x?
to the power of x.
3 to the power of x. Yep. And then what would you write after that then?
So after you substitute it, would it be m squared minus 12 times 3 m?
Ooh, no. 3 to the x is m
Oh, times m
times m. Good job.
plus 27.
Yeah, 3 to the x is m, and this one here is just 3 to the x squared. So that's just m squared. All right, brilliant. And then factorize that.
That would be m minus 9 and m minus 3.
So m equals 9 and m equals 3.
And then
3
you sub it back in.
Now, I mean, in this case here, you didn't have to use logs because you might. Do you know what the answer is for x in both of them?
3 and
Oh, not 3. 3 to
2 and 1, 2 and
2
1.
and 1. Yeah. If for some reason you just weren't sure what x is by just observation, again, don't forget, you've now learned logs. So log it, bring the x down, and then just divide. Plug it into your calculator, you shall get 2. Same thing with this one, you're going to get x log 3 equals log 3. Well, we already know log 3 on log 3 is 1. Anything divided by itself is just 1. Brilliant. Well done, Jan. Sorry, you guys are probably still copying down. All right, let's do another one then. 4 to the x, again, it's just, think of it as 2's, right? Because this is the one you want to substitute. So that's just 2 to the x squared. How come? Because if that 2 was in the inside, that would have been 2 squared, which is 4, 4 to the x. So this is actually just this guy squared. So again, you'll just say let m, or just pick a letter of your name if you want to. Doesn't really matter what letter, right? 2 to the x, and then just go m squared minus 12m plus 32 equals 0. 32, negative 8 and negative 4. Yep. So m is 8, m is 4, 2x equals 8. You can probably see the answer. 2 squared is 4, 2 cubed is 8. If you can't see the answer, log both sides, and then you'll pretty much get log 8 on and log 4 on. All right. Any questions? All right. Let's see if there's nothing else, right? Yeah, we might as well start this one. 5 to the power, so solving simultaneous equations. 5 to the power of x plus y is equal to 1 over 5. And 5 to the 3x plus 2y equals to 1. To be able to equate the left-hand side to the right-hand side, you definitely don't want this 1 on 5 here and the 1 here. Can anyone tell how to rearrange this 1 and the 1 on 5 so that it's in terms of 5s? Write it out. This is, see, this 1 has to be a 5. And this 1 on 5 has to be a 5. So that when the bases are the same, I can say something about the powers. Any ideas? Okay, if you're stuck with that, then we'll just go back to our normal methods, which is, what's the opposite of an exponential? You would log it, right? So log both sides. So don't forget, if you ever get stuck and you've got it on the power, you can just log. So bring the x plus y down. Log 5 equals to log 1 on 5. Therefore, x plus y equals to log 1 on 5 over log 5. Plug that into your calculator, get an answer. You guys are comfortable with what I just did there on the top? I'll just log both sides. You've been doing that, right? So log 1/5 divided by log 5 is -1. So x plus y equals to -1. And 1/5, isn't 1/5 5 to the power of -1? And that's how you can also get x plus y is equal to -1. That's your first equation. Second equation, can anyone see it yet? 5 to the power of what would get me this? Sorry, would get me 1. If you can't, you've just got to do the same thing again. Log both sides. So it would look like this. 3x plus 2y. Log of 5 is equal to the log of 1. We know log of 1 is 0. 0 divided by anything is still 0. Oh. And again, 1. 1 is just 5 to the power of 0, isn't it? That was a sneaky hidden one. Again, now you've got your two equations. You can solve simultaneously. And you should get x equals 2 and y equals -3. I would have probably just done times this thing by 3. So you're left with 3x plus 3y equals -3. Subtracted everything. 2y take away 3y is -y. 3, so therefore y equals to -3. So back into the top. Y equals -3, so -1 plus 3 is just 2. X equals 2. The simultaneous bit is easy. It's more just realizing at the top. So you either learn exponentials, now you can log both sides until you get it out, or in this case, the reason why they gave you 1 on 5 is so that you can realize that that becomes 5 to the power of -1, and then your powers must be the same if your bases are the same. If your bases are the same, then your powers must be the same. So 3x plus 2y equals 0. Graphs, that's all next week. Applications, I'll rather do next week as well. Alright. This book is done. I'll send that to you guys. I've already got this all sorted out, so I'll send you that copy. Here. Using properties of laws, so using your log laws, evaluate these results. So you're not solving as such, you're evaluating. Given that log 3 is 0.562, log 2 is 0.356, and log 7 is 0.872. Find log 18, log 28, log 1 on 21, log 3b squared, log 1. I'll do the first one just as a recap. So question 30, log of 18. Log 18 I know is log 9 times 2. 9 is 3 squared. Yep, I think I got it. Log 18. So 9 squared times 2. No, what? 3 squared times 2. Log 3 squared plus log 2. Bring the 2 down. This becomes 2 times log 3 plus log 2. And then you just plug into your calculator. If you don't have any questions, start from question 31 and just complete the next 4 questions. If you don't know what you're doing, just let me know. If you get stuck somewhere, just let me know. All right. Log 28. Square root, I would first get rid of the square root, so that would become what? Half log 28. 28 to the power of a half, and then bring the half down. 28 is 7 times 4. 4 is 2 squared, so my next line I would be writing is half log 7 times, let's say, just 4. Next line, half log 7 plus log 4, but we know log 4 is 2 squared, and then pretty much from that you get log 7 is 0.872 plus 2 times log 2. Question 32. Log 1 on 21. Same thing. Log 1 minus log 21. Log 1 we know is 0, or you'll just leave it as you need to plug into your calculator. Log 21 is 3 times 7, so that becomes negative. Log, use your brackets. Look how I'm using my brackets. Log 21 is 3 times 7. I know that if I've multiplied, it's the same as me adding, so negative log 3 plus log 7. If you wrote that, it's wrong. The reason why that's wrong is because that whole bracket should have been attached. So this log 3 plus log 7. So now the subtraction sign is for both of them. So log 3 is 0.562 plus 0.872. And you just plug that into your calculator as well. Anyone completed 33 already? Alright, I'll just pause there. With 33, you can't bring the 2 down just yet because the 3 is not attached to the 2. See how this half, this square root here, it's attached to both 28, so you can bring the whole thing down. That squared is not attached to the 3, so you can't bring it down just yet. You'll have to do the product bit first. So 3 times b squared, which means you're adding the logs. It's 33 log 3 times b squared. It becomes log 3 plus log b squared. Log 3 we know is 0.562. This becomes 2 log b. Don't forget this is a b and this is sub-base b. So this technically becomes just 1. Well, of course, last one, log of 1 is just 0. That was an easy one. This section is probably a lot weaker for students than the solving bit. So let's have a look at some of the solving questions, and you'll see. Let me get to differentiation for that. Because I'm not very good. Try that one out. You're solving. Again, you can't cross out the 10s because there's no 10 here, log 10. So I'll give you the first line. Anybody got an answer out for this one?
Yes, Sam, I think so.
What'd you get? X equals
3.
3. I could check it real quick. That becomes 6. 6 on 3 is 2. Why don't I like it? You might be right. I don't know. Can anyone else confirm?
I got 1/3.
1/3. Let's see that one. 3 plus a third is divided by that. I think I like 1/3 more. So let's see what's happened. Boom. All right. All over log 10. So you'd multiply your log 10 over. So you're up to this stage. Then you don't like this being subtracted, so you would divide. Equals log 10. Then you would get rid of your logs. And you'll just have x plus 3 is equal to 10 times x. Bring the x over. 3 divided by 9. Maybe that's where you went wrong. Novak, 3 over 9 is 1 over 3.
Yeah, that's where I went wrong. Yeah, not 3,
Instead of
yeah.
3. Okay. The rest of us, we're getting it. We're starting to get it. Let's try it again. Again, your first line is log x to the power of 5 over log 10 minus 8 equals 3 log x on log 10. I'll let you think about that. times everything again by log 10. Bring the 8 up, bring the 3 up. Then you probably don't. It doesn't really make a difference. You don't really want to have your numbers on this side and your x's on two different sides. So what I would personally prefer you guys learning is to bring your x's on one side and your numbers on the other side, just like always. It didn't matter if you didn't do this. It should not matter at all. But you're still going to divide. X5 over x cubed is just x squared. X5 over x cubed, x squared, equals log 10 to the power of 8. Get rid of your log, square root that. That becomes 10 to the power of 4, which is what, 1,000? 10,000? If you did not do that, you would have had x5 over 10 to the 8 equals x cubed. Then you would have multiplied your 10 to the 8 to one side. Let's see if you guys didn't do that. It would look something like this. Then you would have multiplied this. Then you would have had to get rid of your x cubed because you can't have it on this side. So you would have divided by x cubed. And you would have still got it and ended up with that result. Try it again. Unless you guys got questions for that one, try the next one. This one, ln 2x minus 1 over ln 3 equals 2. Bring the log 3 over. You're starting to realize it's almost the same question over and over again. The 2 goes to the top, cross out your logs. You get 2x minus 1 equals to 9. 2x equals 10. X equals 5, sub back in, 2 times 5, take by 1, looks good. Any questions? Let's have some exponential equations. No, not differentiate. And then integrate. There you go, look at that. HSC question worth 2 marks to solve this. E to the x equals 4. What do we do to both sides?
ln both sides. Yeah.
Perfect. Log e just becomes 1. So your answer is log 4. But you got yourself 1 mark. It says 3 sig figs. So plug log 4 into your calculator. It's 1.3 1.39. 1, 2, 3 significant figures. That's another HC question. Solve the following for x. We should know that that's a quadratic. What do we let m equal to? Middle term, which would be this, will be.
2 to the power of
Yeah. And then this becomes what? 2ex squared. So that's 2m squared minus m. And factorize your m out. Plus 1 divided by 2 is a half. E to the x is 0. E to the x is half. You can't log 0, so there's no solution for that one. The answer here is just going to be log of a half. Because when you log e again, doesn't do nothing. Easy 2 marks for HSC. Here's another one. Here's another one. 3 marks. So there must be a trick to it. All right, ln x, log e is ln. Right, it's got the same, it's got that base e, so you can just convert that to ln. Minus 3 on ln x equals 2. At this stage, I would multiply everything by log x, so this would look like this. I know I don't want this on this side, so I'll bring it over. Now this looks like a quadratic with m equaling to log x this time. The reason why I've got to do that is because I've got the squared term here. And then you just do everything the same, right? M squared, take away 2m, take away 3, and then m take away 3, blah, 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 blah. Everything you know. M equals 3, m equals minus 1, and then what do we have? M is log x, so log x equals 3, log x equals negative 1. How do we get rid of the log? This time we exponential both sides. So your answer is e to the power of 3. In this case, it's e to the power of negative 1. We haven't seen just yet. That was worth 3 marks.
Sam, what were the 2 solutions to the last question?
Just log equals half.
Okay.
And another one. Solve 2 marks. Oh, these ones are good. 2 marks. Solve the equation ln x equals 2. Well, what do you do to both sides? How do I get rid of the log? You exponential both sides. So x equals just e to the power of 2. And so write it as 4 decimal places. So plug that into your calculator. E power of 2, 7.3891. And let's have the equation. Okay, that would confuse a lot of students. It says find alpha so that the equation of this can be written as this. A lot of students who are not comfortable with exam questions obviously get very stumped by that, but all it's saying is that, well, hundred's the same, so you can kind of ignore that bit. It's just saying that you know that e to the power of alpha, must equal to 1.23. See how you can conclude that? Again, t is the same, so pretty much e to the alpha must be 1.23 for you to be able to write this as this. Log both sides to get rid of the exponential, and really you're done. So alpha log e equals log of 1.23. Log e is gone. Log of 1.23, write it in decimal form, is 0.207 to 3 dp. Yep, I think that's it. That's off the graphs as well. Literally covered all of the beginning of logs. So that's good. We've just got the graphs to go. I'll revise all of this again next week, and then we'll start graphs. Graphs will only take us about an hour, and then we'll do the applications questions. I will send all this booklet to you guys now as well, and this as well. Extension 1. All right, stop. We're doing well. If you've got any questions,